On 2.3 part 2, we're trying to determine if functions are linear, exponential, or neither, and whether they're continuous or discrete. So this one, I know that this is an exponential function because it is showing that J curve. So if you also look at your points, that one goes up one, right one, up two, right one. So we had a slope, an average rate of change of 1, then 2, then 4. So that is multiplying by 2. Also, on our graph, because the points are connected, it is continuous. And the domain of this function, it goes forever to the left, where all the negative numbers are, and forever to the right, where all the positive numbers are. We use parentheses because you cannot reach infinity or negative infinity. The next one, y equals 2x plus 4, is set up like slope-intercept form. So therefore, it's linear. Now, because there's no context with it, we assume that it is continuous, which means that because it's linear and all points make sense, we have to indicate that all points make sense. So again, without context to back it, this is continuous. It is aligned with arrows on both ends, which means the domain goes from negative infinity to positive infinity. This next one, we have 5, 11, 17, 23. So I know I'm adding 6, add 6, add 6, but you also have to look at your x values. So we have add 2, add 2, add 2. So rate of change is your change in y divided by your change in x, which gives us 3. We're adding, so it's linear. There's no context, so we assume it's continuous. It wants our equation, so we've got y equals 3 as our rate of change, which is always touching x, plus 5, which is our beginning amount, your y-intercept. Again, this is a straight line with arrows on both ends because there's no context, which means it's going to go towards the negatives for infinity and the positives for infinity. Number 4. You invest $4,000 in a company and earn a 5% profit. That means we're adding an extra 5% to the money you already had. So you get to keep 100% of your money and an additional 5%. So on this one, which is exponential, we start with $4,000 and we get 105% of our money, which is the decimal 1.05, x in the exponent. Now, because you're getting money at the end of each year, this is discrete. In your domain, those years is going to be at year 0, 1, 2, 3, etc. Because that's when you're earning the interest. It's at the end of year 0, at the end of year, well, not at the end of year 0, but you have money at year 0. You earn money at the end of year 1, the end of year 2, the end of year 3. Joe has a jar of 300 Reese's Pieces. Every hour he reaches in and gets out 10 pieces and then eats them quickly. So every single time he's getting out 10 pieces, which means we're subtracting 10, which is linear, and it's every hour. He's getting all 10 of them at once, which means it's discrete. So our equation is y equals, he's taking away 10 pieces every hour, and he had 300 pieces in the beginning. So your domain, those number of hours, because it's discrete, we use the funky brackets. And at the end of hour 0, he has 300. At the end of hour 1, he has 10 less. Hour 2, 10 less. Hour 3, 10 less. On to the back. This one we have, I know that 4 plus 8 is 12, but 12 plus 8 is not 36. So another way to look at this is by multiplying by 3, which does work the whole way through, which means this is exponential. Because there's no context, we assume that it's continuous. And when we write our equation, we have y equals 4 times 3 x in the exponent. Now, just like linear functions, without context, it's forever going to the left and forever going to the right. So our domain is negative infinity to positive infinity. So on the next one, we have cashiers and items scanned. To go from 20 to 40 to 60 to 80, I'm adding 20, which lets me know it's linear. Now, I'm not going to have half of a cashier. I have 1 cashier, 2 cashiers, 3 cashiers, 4 cashiers. So this is discrete, and my domain shows it. I have 1 cashier, 2 cashiers, 3 cashiers, 4 cashiers. And when we write our equation, we have y equals our rate of change is 20, rate of change is always touching x, and then our beginning amount. So if we're adding 20 going down the table, if we subtract 20 to get that 0 amount, it ends up 0. So we're done with our equation. The next one is a straight line, which means it is linear. The points that make up the line are connected, so it is continuous. We see that on both ends there's an arrow, so it's going from negative infinity to positive infinity. And the equation, it has a y-intercept of -4. There's our next pretty point where 2 grid lines meet the line, and it rises to runs 1. So rise over run gives me a slope of 2. So I have 2x, y equals 2x minus 4. For this one, if I check the slope of these points, I see that I go down 4 to the right 2 on each of them, down 4 to the right 2, but they are not connected by a line. It's still linear because it has the same rate of change, down 4, right 2. But because it's dots on a graph, it's discrete, and our slope is -2. So when we write our equation, we have y equals -2x, and your y-intercept is -2. Now your domain on this one, we only identify the x values where there is a point. So we have a point at -4 as an x value, at -2 as an x value, at 0, and at 2. That's it. And the last one, 100, 200, 400, 800 is exponential because you're multiplying by 2, which means our equation is 100 times 2 to the x, because we use the 0 term, your y-intercept. So because this is talking about the profit earned each year, we're going to assume this is discrete, that the profit is only calculated at the end of the year, because you may have months with profit and some months with loss. So we're going to look at it at the end of the year, which means our domain is going to be all of the values in the left-hand column, 0, 1, 2, 3, and we can assume that it continues following the same pattern.